Okay, so far we have seen how two variable and three variable maps are working. Let's see how four variable map is going to work. Now, four variable map means we are actually having 16 minterms because let's say A, B, C, D, or W, X, Y, Z starts from 0, 0, 0, 0, and it goes down to 1, 1, 1, 1, 0 to 15. So we have got in total 16 minterms. 16 minterm means 2 to the power 4, 16. So we need 16 squares for each minterm. And the combinations that we can have with 16 minterms, again, powers of 2, either 2, 4, 8, or 16 adjacent squares. And we always aim for the largest possible combination. So 16 square means we'll have a larger, it looks like a square now, divided into 16 squares. And we have got A, B, C, D. So 2 on both sides. Again, we are using gray codes, 0, 0, 0, 1, 1, 1, 1, 0. And we do the same thing for the rows as well, 0, 0, 0, 1, 1, 1, 1, 0. Now the minterms, it looks like complicated, but it is not. 0, 0, 0 is minterm 0, 0, 0, 1 is minterm 1, 0, 0, 1, 0 is 2, this is 3, 0, 1, 0, 0 is 4, 5, 6, and 7. This is exactly the same as three variable map. Then, as we have got 1, 1 over here and 1, 0 over here, that means minterm 8 is over here, 1, 0, 0, 0. Then minterm 9, minterm 10, minterm 11. And minterm 12, 1, 1, 0, minterm 13, 15, and 14. So this is the map that we are going to work on. And this is one of the most used one. Now, the combinations. So like we have done in three variable map, we have got interesting combinations on four variable one as well, because as we have got lots of adjacent squares to each other. So I'll start with a simple one. So the largest possible combination is 16 squares together. This is one of the combinations. Then you can have half of it, or maybe the other half, or you can have it horizontally, or you can have it, this is again, rather than having 4, I can do it this 4 and this for 8, both sides, or you can have the corners, because corners can join up to have a square of 4. This is also possible. And of course, the centers, you can have it, or another one, the top 2, or top 4, and bottom 4, or bottom 2. So these are all possibilities that we can have with four variable map. The one thing that we may have to be make sure, either in a 3 variable or 4 variable or on 2 variable, we cannot go diagonals. Okay, we cannot do diagonals. This is the property. Okay, let's see the first example. As you can see, we have more minterms now. All right, so the function is given. I have to draw the K-map. 16 possibilities. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, and we have got W, X, Y, and Z. So midterm 0, I suggest you to write them as well. 3, 2, 4, 5, oops, 7, 6, 8, 9, 11, 10, 12, 13, 15, and 14. Okay, then let's put down our minterms. Minterm 0 is going to be 1, 1, 2, 4, 5, 6, 8, 9, 12, 13, and 14. So we have got all those as 1s and the others are 0s. Okay, so at first sight, I can see the largest possible rectangle are those 8 of those. Now, Wx is all changing. What is not changing is y0 stays 0. I can say that this red rectangle is y prime. Then I can see clearly that I can join these two and these two, which the green one is going to give us W is always 0, X is changing, and Y is 0, Y is changing, so Z is 0, stays 0. So W prime, Z prime for the green one. And we have one more as we can combine these two and these two, and this will give us X is not changing, and it's Z prime again. So in the end, I can write the expression for some of them in terms y prime or w prime z prime or x z prime. So same in terms, combine them, and you will get the same expression. Please try by yourself. If you have questions, note them down and feel free to ask them in the live session. Okay, another example. Now again, the expression is given, we have to map it. So I'm just deriving the Carnot map. Where I have got A, B, C, and D. So I don't need the midterm numbers, it's given over here, but I'll go with the expression. So A prime, C prime, D prime. So A is 0, C is 0, D is 0. B, both 0 and 1. So where do we have got A0? I'll just use different color. A is 0 at these 2 points. B is changing. C is 0, D is 0. So C is 0, D is 0. So those two squares are going to be 1. So that's the first one. Then A prime D. So A is 0 again, and D is 1. So we don't care about B and C as it is not written. So D is 1 at these 2 points. So that means those 4 of those, because B is changing and C is changing, we just put those as 1s. Then we have got B prime C. So B is going to be 0. I'll change the color slightly. B is 0 at those 2 points, and C is always 1. C is 1 at these 2 points. So that means these and these together. So B primes and C is 1. So this columns and these 2 rows. So this is going to be 1, this is going to be 1, and this is going to be 1. As C is 1 at these points and B is 0. Then I have got CD. CD is that column, so it's always going to be 1. So I just put over the missing 1. And the last one is A is 1. So where do we have got A is 1? A is 1 is over here. B prime, it has to be B prime, so it has to be this one. And D prime. So D prime is those 2 points. So D prime are those 2 points. And we know it's AB prime, so that means this one left outside and the rest is over there. And I can fill the rest of it as zeros. Now the combinations. I can see that I can combine the corners as they're all valid. So the corners are going to give us B prime is not changing and D prime is not changing. So B prime, D prime are the corners which are written in red. Then I can have these 4, which is an orange one. A is 0, C is 0. So A prime, C prime. And I can have one more, which is complete rectangle, which is CD. So the expression for it, F is equal, simplified expression is B prime, D prime, or A prime, C prime, or CD. And these are how 4 variable K-maps are working. Now, the next thing that I want to cover is about implicants. So what are the implicants? What do we need to know about implicants? Now, any product term that we have got over here is an implicant. Okay? So any of the product terms that we have got, which is representing 1, they are implicants. Now, we also have prime implicants. Prime implicant is a product term obtained by combining the maximum possible number of adjacent squares. Okay, so you might have 2 of those. That's a prime implicant. Implicant. But when you combine 4 or maybe 8, that becomes prime implicant. And we also have essential prime implicants. Essential prime implicants, which I'm going to demonstrate it, when you have a prime implicant and that prime implicant, any of the members cannot be combined with another prime implicant, we can say that that is essential. So there is no alternative way of representing that. So let's see an example. We have got an expression. I have to draw a 4 variable K-map. All the min terms are given for us. We have got A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. I'll write the min-term numbers 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, and 14. All right. Now, let's put down our numbers. So 0, 2, 3, 5, 7, 8, 9, 10, 11, 13, and 15. So this is how it looks like. And let's find out the implicants, the prime implicants first, and then we can decide which ones are essential, which ones are not. Okay, so I can see the corners again, which is equivalent to B prime, D prime. That's the first one. Then, another combination that I can have, the center, the orange one, which is B and D. Then I can have these four together, which is CD. A and B is changing. I can also have the down row so that I can combine 9, and that will be A, B prime. Now, I have got one more, or two more, let's say. One of them is over here. It's redundant, but I can have it. So A is not changing, and D is not changing. And also, I can have the top two and bottom two. And this will be B prime C. Now, these are all the prime implicants that I can get. The maximum possible combination is 4, and these are all alternatives. Now, which ones are essential? And which ones are just prime implicants? Okay, the first one that we have found was B prime, D prime. Now, when we look at the B prime, D prime, we have to look at each individual term or one in that B prime, D prime. So min term 0. When you look at min term 0, maybe that's not readable. I need to find another color. Min term 0 over here. When you look at it, can it be combined with anything else? 1 is empty, 4 is empty, it cannot go diagonal. Okay. 2 can be combined with 3 and 10 and 11. Okay. 8 can be combined with 9, alternatively to the corner. 10 can be combined with 11. But as 0 cannot be combined with anything else, min term 0, we can say that B prime, D prime is essential. Okay, it has to be there as 0 cannot be combined with any other prime implicants. The second one was BD. 7 can be combined with 3, 15 can be combined with 11, 13 can be combined with 9. 5 cannot be combined with anything else. So we can say that BD is also essential. Let's look at CD. CD, 3 can be combined with 2, 7 can be combined with 5, 15 can be combined with 13, and 11 can be combined with 9, alternative to the green one. they can be combined, so it's just a prime implicant. Then we have got AB prime, which is the blue one. 8 can be combined with 0 as the corners. 9 can be combined with 13. 11 can be combined with 15. And 10 can be combined with the corner or with the 2. So it's not essential. I can say it's A, B prime is just prime implicant. Then the red one, dark red one. So this is going to be 13 can be combined with 5, 15 can be combined with 7, and 9 can be combined with 8, and 11 can be combined with 10 as well. So it's not essential, it's just a prime implicant. And we have got B prime C. 11 can be combined with 9, 3 can be combined with 7, 2 can be combined with 0, so it's not essential, it's just a prime implicant. So we have got the essential ones and the prime implicant ones, and we can say that when we want to write an expression, these are must be there. And these are based on the alternative combinations without getting a redundant nodes, we can have the combinations. So as you can see, BD and B prime D prime is always there. We can have 4 alternative expressions. CD and AD is used, CD and AB prime is used, B prime C and AD is used, and B prime C AB prime is used. Okay, so you can create 4 alternative ones, but these essential ones are written for all of those. Another one. So simplify the Boolean function represented by the K-map. Now we have got all the variables on the map. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So 1, 1, 1, 1, 1, 1, 1, 1. Now the combination, I can have those 4, which is going to give me A prime and D. And also as an alternative, I can go for those, which is going to be B is constant and D prime, B, D prime. There's a redundant one, which is this one, the blue, and this is A prime B. But again, it's redundant. Which ones are essential? Now, when we look at this one, which is min term 1, it cannot be combined with anything else. So adjacently, it can only be combined with this square. So A prime D is essential. Okay. BD prime. Now, this one can be combined. This one cannot be combined with anything else. Okay. So BD prime or this one cannot be combined with anything else. BD prime is also essential. And this one is not essential and it's redundant. You don't need to include it. We can just say it's A prime D or B D prime. So another example related with the implicants. Now, I'm not going to solve that. I can go through over here. This is individual. It cannot be combined with anything else. These can be combined as 2. These can be combined as 2. These can be combined as 2, or this can be combined as 2. So this is A prime, B prime, C prime, D. We have got B, C prime. This is B, C prime, D. And we have got A, B, C prime, these two. And we have got A, B prime, C. Okay, so this one either can be combined like that or like that. Either it is A, C, D, or it can be A, B, D. So you can have all those.